Hey, how it's going, guys? In this video, I'm going to show you a radiology AI project that I have been working on. Okay, it's a tool that I have been building using AI agents. Okay, and this is mainly in AI in healthcare. That's what I've been doing here. So if you look at here on my screen, I have this interface that currently you see might be a bit overwhelming, but I will just break it down for you. So if you look at here from the left-hand side, we have a sidebar, where we have some, features like connector, analysis, QA chatbot, and then we have a patient queue, all the patients in the queue, which are basically sanitized, right? These are not real patients. And then on the medical image viewer, we have the image which is coming from your PACS systems or PACS integrations coming from your machines, right? And then on the right hand side, the top right, we have the radiology report that you see here. It's all AI generated analysis. There is no human intervention, no and a human radiologist are basically analyzing this. So AI in healthcare is a booming thing actually globally. It's a big market also. And now everybody is trying to build one thing or the other in that particular industry. And within the healthcare, there are different verticals or domains that people are kind of, building. Right, you have clinical workflow, you have diagnosis. We have somebody's building diagnostics system, somebody is building uh, workflows for automating administrative side, mainly on the clinical workflow side. Some of them are building generating synthetic data, building virtual assistants, chart reviews, so on and so forth. But radiologists, they are like, I believe there are solutions. There are, companies like Cure.ai and SigTuple, and there are a lot of companies globally who are trying to solve a lot of problems in that field, but it's still really an untapped market, I'll say, when you compare that with other domains. So this tool that you see is a tool that basically is completely on-premise, no cloud APIs, no third-party models because of all the compliance issue. Because when we work with these kind of solutions, we have to make sure that we are HIPAA compliant, we are compliant with whatever geography we operate in. Uh, we have to be compliant, right, from data to models to the infrastructure layer, right? All the layer, there should be governance in that field. So it's not an easy task to kind of work, with artificial intelligence or AI or agentic AI, whatever you call it nowadays, in that particular domain. That's why I have built this completely, and I will walk you through completely on-premise, open source, no third-party models, no APIs, nothing. Okay, so if you look at here, it analyzes it and it says this visualized bony structures appear intact. There is increased density within the abdomen, which could represent bowel gas or other soft tissue densities. No obvious acute fractures are identified. This is the image that you see here. It's basically a DICOM image. So this tool also supports DICOM images. If you are somebody who have been working in this field will definitely understand what DICOM images mean. So this is not a JPEG or a PNG format image. It's a DICOM image that directly comes from your system, and I'll show you how it basically works in real world, in the real hospital or a diagnostic center. Right now, these output have been categorized into three categories. One is findings, impression, and recommendations. So if you look at the impression part here, it says clinical impression. Abdominal radio density appears increased. So it's an abdominal. If you see here, it looks a bit inflamed, basically. If I'm not wrong, actually, the density looks a bit increased looking at this particular DICOM image, and it says further evaluation may be warranted depending on clinical context. Clinical correlations with patient symptoms and history is recommended. Consider further imaging, CT, abdomen, pelvis, if clinically indicated. This is important, guys, because here the way I have designed the prompts also, I have to ensure it by putting some guardrails that it doesn't make any diagnostic decisions. It's not a diagnosis engine, basically, right? It's not going to do any diagnosis. So it's not going to do any differential diagnosis also in that way. I don't want to build tools which is going to influence decisions of radiologists or doctors or clinicians. That doesn't make sense, right? It should just bring up all the anomalies and insights and let the domain experts decide, or the practitioner to decide what they want to do with this. Now, let's say if the end user, who is a radiologist in this case, if they're not happy with this output, they can do a couple of things. One, they can agree with AI findings. So you can see agree and disagree. Let's say if I click on disagree, they can put their feedback. The reason being, because I want to collect feedback data also, right? That will help me later fine tune. When I'm fine tuning on this feedback data, I can align the model better because these are all open source model. I can control it better. When it's open source LLMs, right? Medical LLMs. I'm using MedGemma, behind the scene as a large language model, as a medical model. And there are other models for segmentation that I will show you. But that's what I'm trying to say. So the feedback data can be used to align better. We can use alignment techniques, on these feedback data to kind of improve the model. So that's why I'm taking feedback. That's the one thing. Now, the other thing is you can also edit this. Let's say you are not happy with this output. You can always edit the AI outputs. You can see when I click on here, it becomes an editable input box. So you can always edit your perspective, right? And when you can edit and update report also. I'm not going to do that because I don't know if that's true or not. I'm not a domain expert, right? So I'm not doing it. Now, this is one thing. Now, here the question that this is fine because this is an external interface, right? How does this interact from the data input to the output, right? The output that has been generated. So mostly what happens is when we are working with the bigger hospitals or, mainly in the healthcare industry, these kind of systems are integrated with the EHR or the EMRs of the world, electronic health record or electronic medical record, like Epic, for example, Cerner, for example. There are a lot of others, Athena, for example, and so on and so forth. Now, for that we have to make sure these are FHIR compliant, like this has to be in that format. So we also have that option here in this tool. If you look at in this tool, it says FHIR diagnostic report JSON. It's basically a JSON schema that is pretty much compatible, and of course you can customize that further based on what EHR you uses it. But yeah, if you look at here, it's entirely is completely FHIR compliant. You can see it follows FHIR R4. So there are R4, R3, etc. You can see FHIR R4, the standard. You can download this, copy this, so on and so forth. So you can also do that. Now the other thing is I shown you the edit part, and I'm showing you this FHIR part also. And the next thing is you can also download or print this report. So if I'll just show you, you can see the printer just opened here. I'll just cancel it. Now, I'm not letting user to download a PDF file because let's say in the real world setting, you will not let them directly create PDF reports from this because it has to follow the compliance, right? There's a process of it. It has to go into EHR, has to follow some templates, sanitize, etc., and then create a patient version of that report. So here I'm creating an HTML file just for the radiologist to kind of see. And you can see this is how it looks like, right? Findings, clinical impressions, recommendations, and of course this can get improved as per as better domain understanding. So if you are someone who works in this field, happy to take your feedback and iterate later. But yeah, here is the icon is edit, FHIR, and print. This is one thing, and the same is here also. Export report, you can just export this report in again in HTML. So if you just click on here, it opens that HTML. Now export, and of course you can update this back to your EHR. So EHR character is still not there in this interface. The scope is beyond of this tool. That requires further integrations with EHR or EMRs. They would have their API endpoints. We have to interact with those API endpoints to kind of integrate these kind of interfaces. Now that's the one thing. Also has a pretty much intuitive design aspect to bring up light and dark theme over here. That you see. Not only that, have a little bit of UX here to help radiologists, because in the radiology domain, right, we have annotations. We have to do annotations. We have to save kind of our own, labels, etc. So here you can also zoom in, zoom out. Let's say if you want to label also, I'm going to integrate those libraries that can help you label certain things to collect some kind of annotated data also. Now, if you look at here, brightness, you can always reset and get back to it. So that's what it is. Click here, go back. Same thing, you can also rotate this. So we have that, like, you know, yeah, amazing, right? And you can again do it from here. You can also maximize this. If you maximize, you can see it over here that we did maximize it. Now, so you can again minimize it further. If you agree, you can just hit agree. It saves in the database. Segmentation is something that I've been working on. So for segmentation, there is models like MedSAM that have been fine-tuned. MedSAM is a model by Meta that has been further fine-tuned on medical data sets, annotated data sets for labeling, for segmenting. Uh, it's really good though, right? Because when you do segmentation, you can see 70% segmentation ready. There is a number that it kind of gives it. It does not work good on all kind of medical images. It works really good, for X-ray guys. I've seen that. Excuse me, CT scans. It works really good with CT scans, not with X-rays. So you can see the segmentation. You can always hide it, show it. You can increase the opacity, decrease the opacity, and everything is handling within this session state. So you don't have to run it again and again. So those kind of engineering have been done. So if you look at here, so it brings up that. Now this is the radiology reports side that I have shown you. Not also that, the thing is, it also has your contextual information, bringing up some similar case studies. Like let's say a radiologist find out that this is a very complex case and want to correlate with any study that have been done previously. So I have integrations with PubMed, and you can do it with UpToDate and so on and so forth. So if you look at here on PubMed, if you click on this, it takes you to this PubMed. It says a case study on a retained surgical towel leading to an intra-abdominal abscess post hysterectomy, right? So we have such things as well. It also gives you some entities to kind of do your own case studies, find out abdominal radiodensity appears, characterize abdominal findings, just some bullet pointers just had been generated from this particular report that you see. And it has integrations with PubMed. You can find out different types of case studies. You can say this is a different case study that says post-herpetic abdominal pseudo hernia with under-recognized characteristic of male predominance and co-occurring fatal visceral herniation, a case report and a literature review. So this basically brings up some correlations for you to study and find out if this is making any sense, right? And this can probably help you answer some of your questions related to these anomalies or findings. So this is one thing. Now the other thing is here that I've been already shown you. You can see this patient queues have been sanitized, and let's go back to our new analysis, which is important. I want to highlight that because I have covered all of these part actually, the findings and everything. So let me just go back and show you the new analysis. Now, right now I have shown you by uploading an image, but this also has DICOM connector status. So let's say in the real hospital settings, right? When you are connecting with any diagnostic center or any hospital that you want to work with, you have to connect with the PAC server that basically has to run it locally. There are PAC server, there are city modality, there are DICOM gateways called Chi gateways, for example, and this runs on all these ports, IP addresses, MR modality. So there are different things that it has to connect with and bring all that streaming data, or even not streaming is fine. Even if it post the session, it can come up and you can generate in a minute or two, right? So this is how it will work in real setting. It has to be through DICOM connector status. Right now I shown you by uploading an image. That was a DICOM image. You can see it says image.dcm. That's the image. You can, let's say you want to upload a new image. I'll show you by uploading a new image actually. Let me find out here, DCM. When I do that, right, I can upload this particular image, and it automatically, you can see it says uploading and processing. If I come back here in my terminal, I want to show you that nothing hidden actually, guys. Everything is like behind. You can see it, everything is here, right? You can see it's running. It runs here. You can find out it's running. It's everything is locally running. And I will walk you through the architecture in a little bit. I don't want to create a very lengthy video on this. If you want to build such tools also, I'll tell you how you can build it. It's not rocket science to do it basically, but you should have some understanding, in-depth understanding of regulations, compliances, how to manage the infrastructure, how to build governance layer, right? You have to make sure there is no hallucinations, there is no, uh, you know, biasness and so on and so forth. Let's go back now on this one. You can see it says uploading and processing 100% complete, as everything is running locally and it does not use any GPU as of now. I'm running it on my Mac machine, so it uses the Mac chip and no GPU as such that it can utilize it on the CUDA side. It has some accelerator from the Mac and it runs completely locally on premise open source. It's going to take a few minutes for you. Meanwhile, it's doing that. what we can do, we can go back and I can show you this architecture just to walk you through that how this have been completely designed and engineered. So if you look at it, I call it enterprise radiology AI platform architecture. This is how your hospital infrastructure will look like, right? You will have your CT scanner, you will have your MRI scanner, you will have your X-ray, ultrasound, USG, whatever you call it. You will have your picture archiving, that's called PACS server. Then you will have your HIS, Hospital Information Systems, or EMR, or you will have your RIS separately. So HIS, RIS, all this hospital infrastructure, we're working with the bigger hospitals. This is our infrastructure on the hospital side. Now it has your all the DICOM stores, C store, whatever you call it. Patient data will come from EMR that will bring the contextual information in the entire patient chart, the previous history of patients. You have all this DICOM C store, DICOM query retrievals. You will have your HL7 for RIS. HL7 is again a standard protocol for patient data exchanges. So you have all of your hospital infrastructure, and then we have our standard integration layer. For the medical images, we'll have DICOM Gateway. That's called Chi, basically. Chi Gateway is an example. And for patient data, like text-based or PDFs, unstructured data, that will go through HL7, V2, FHIR, so on and so forth, right? And and then you can see we have a work list, modality work list over here for DICOM images. And then we'll have patient context. Now that will come to our API gateway, which is FastAPI, built-in FastAPI, that you see it over here. And basically for security and compliance, make sure that end-to-end encryption is happening. Right now, this is not there in this tool. I'll be very honest, brutally honest. HIPAA compliance, that is more of doing it later on. Audit trail, I have some logging. I'm creating a JSON file, log.json, to hold it. And then, we should have a web dashboard, medical image viewer that you see, I've shown you, and a mobile app. I think that is very important. A mobile app, mobile radiologist app. So this is how it will look like. Let's come this a bit right hand side. Here is all the magic happens, guys, right? So we have a AI processing engine. I think that is something you will be interested in. So I'm using LMStudio and I'm using Act module because this can help you build tools, and agent can use it, the tools and the open source models. So you can see local LLM runtime. It uses open source medical LLMs, and then it also has a segmentation model that I told you, the fine-tuned MedSAM model. And it uses, you can see it over here, the radiology analysis engine. It also has PubMed research database, up-to-date clinical decisions, medical guidelines, protocols. These are basically your medical knowledge bases that will help you, make the contextual information more richer. Okay, so that's what it does here, clinical context and literature search. And then we have a QA chatbot engine. I will show you that. Then we have medical image processing that you see. And then we have a report generation and validation agent. So there are different agents that we have. It generates PDFs, it does segmentations, annotations, so on and so forth. So this is our AI, complete the AI engine part here, completely that you see. And then we have FHIR export, the JSON, the reports, findings, so on and so forth, and goes back to this EHR over here. If you see this, all the report storage goes back into these systems. Basically, here is the legend. Solid lines that you see are more volumes. These are the things. Dash lines are clinical integrations that we see, and thick lines are high volume. Okay, that's what it is. Okay, solid lines are primary data flow. Okay, that you see this one. Okay, and these are the greens ones that you see are high volume actually. This is a very, probably this is too overwhelming for you, but this is an architecture. I love architectures, guys. I love AI architectures, right? All types of architectures. I create my own ways of architecture. This is that you see, it's a graph which architecture that I created based on the project. So these kind of things have done, I think 50 to 60% of these things have been done, have been implemented in this system. So you can see now the results have been published. Actually, you can see this is, it says 200. Okay, okay, okay. If you see, it says this is a spinal cord image that you see. It says the image shows a T2. Let me make it a white so you can see it, also light background if you want. The image shows a T2 weighted MRI of the thoracic spine. There are no obvious acute bony abnormalities such as fractures or dislocations. The intervertebral discs appear generally normal in signal intensity with no evidence of significant disc herniation or extrusion. No acute finding on the single slice. This is a single slice. We might need multiple slices from different directions or dimensions. A complete evaluation is required. You can also find out MRI thoracic span is the key terms. intervertebral discs appear as the other one. And it also gives you some other kind of case studies that you see it over here. You can see reversible encephalopathy syndrome with spinal cord involvement. This is fantastic, amazing, guys. And you can copy each sections if you want to put it manually to the EHR systems. Again, this gets generated. You can see these are all happening dynamic, all functional, nothing hard coded actually. Only these part have been sanitized and hard coded just to make sure we are not exposing any patient data. I don't want to expose any patient data, right, from anywhere, like even taking it from Radiology or NCBI or any internet. I don't want to do that. So I have sanitized all of this that you see and then build this. Not only that, this radiology part is correct. You can see the connectors over here that we can go back. Now we also have a QA chatbot. Now this QA chatbot, what it does, the QA chatbot will have all the previously generated reports, excuse me, and then let's say as a junior radiologist or any practitioner who's working in that team, of radiologists, right? They can also select one of the reports, and you can see the moment I select, it says I have analyzed the CT chest for John Doe. What questions do you have about these reports? Let's say I ask about the findings. The moment I do findings, you can see it says the CT scan shows mild ground glass opacities in the right lower lobe, consistent with early inflammatory changes, no evidence of consolidation, pleural effusion, or pneumothorax. Mediastinal and hilar structures appear normal. No significant, I don't know how to pronounce here this. I mean, the guys who have done those degrees, credits to you guys. It's like very difficult space to kind of work and stuff, right? So here you see this. Uh, it says it also gives you real-time status that segmentation model is ready, medical LLMs is ready. I'm using QDRANT for this. QDRANT has been used as a vector database, and you can see everything is there because it stores in database. Even if you change the tab, it will not disappear. So those kind of engineering, everything has been kept in a local database for now. Okay, as I said, everything is on premise. We're using MongoDB, Azure DB to kind of store this locally, self-hosted. Entire application is self-hosted, guys, because you need control if you're working in this field, because AI is a risky technology. Trust me, it can, at a certain time, it can backfire, right? And once something is wrong, you are done actually. You'll be gone. Like companies are like being shut down because of the failures, and because of their leaders have made wrong decisions because there were no AI awareness, right? They read something on internet and they ask their team to do it, or they ask their vendor to implement that way. If you haven't done it, try to learn and adapt. So this is what it is. If you have any questions or feedbacks, let's say if you're working in this similar industry, or if you are somebody who are expert in this field, who you think can help improve this product, let me know. If you want to use this also, let me know. Happy to connect and see how we can do that. And if you have any question, thoughts, or feedbacks, let me know in the comment box. You can also reach out to me through my social media channel. Find those information on channel banner and channel about us. And you can also find those in this video description. If you like this, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos in near future. That's all for this video. Thank you so much for watching. See you in the next one.